Okay, testing 1, 2's the perfect. It's recording. Okay, I'll give you all a few minutes to get Unreal Engine loaded up and kind of open up what we were working on last class, which is this basic surface material. Bit of class time to, I guess, experiment a little bit if there's any particular materials you want to try creating. Water, glass, ice, whatever. We can certainly take a look at different rendering models as well. But we're going to start with some simpler stuff. So where we left last class is we had imported these textures. And we had found these on a website called Ambient CG. I realized I forgot to post the links to the sources of different materials. I'll be sure to do that at the end of class today. So here we have our base color texture, our roughness texture, our normal texture, our displacement texture, and our ambient occlusion texture. Okay. And all of these textures just represent different physical properties of the material. So obviously the base color represents the color. The roughness texture represents how rough it should be. The normal represents all of the kind of little facets and little changes in direction and lighting on the material. Displacement represents the height. And ambient occlusion represents the way that light gets captured in all of the nooks and crannies of a material. So what I want to do now is to be able to scale my material. Because right now, I can change the shape of these things here on the bottom with these buttons here. I can look at it on a cylinder. I'm going to click on this plane because this is a really good way to pre-visualize it, right? You can change the shape, the preview shape. If you have a 3D model that you want to preview, you can select it in your content browser and click this button too. But right now, I'm just going to use this plane to pre-visualize things. Now, I believe I downloaded 1K textures, and a good way to think about how textures work and what size they are is through something called texel density, which is a fancy way of saying how many pixels per meter do you have, right? And a good rule of thumb is 1,024 pixels per meter. That's a good, safe bet. But you also have other texture sizes. You could have 2,048, you could have 4,096, and we may need to scale those textures to make sure that the resolution that we project them into the world matches all of the other textures that we have. So we want to be able to size these textures up and down inside of our material. And to do that, we're going to manipulate something called UVs, or texture coordinates. I'm just going to find a cube here to show you what I mean by UVs. I'm going to find my blueprints. I believe I have just a simple cube here. You don't have to follow along with this part. I'm just using this to demonstrate, so you don't need to, I'm not evaluating you based on whether you can find UVs in Unreal Engine. So here we have a 3D model. This is the cube that's provided by Unreal Engine. I go to this UV here and I click on UV channel 0. You can see we get this kind of grid of points and lines. And what this is a 2D representation of our 3D object, right? So has anyone here ever done origami? Like you folded up paper into 3D objects? That's what this is, right? What we've done is we've unfolded it into a square piece of paper. And what this does is, let's say this point down here represents this vertex on our 3D model. This is what tells our computer how our texture should be projected on our 3D model, right? Because our textures are 2D, our models are 3D, so we need to do a bit of math to translate the, basically a 2D projection into 3D space. And this is how we do it 99% of the time, is with texture coordinates. And every 3D model will have different texture coordinates, okay? So this is what we're going to use to control how we project our textures. This is also why it's really important that textures be square, right? Because all of our texture coordinates are square. You can imagine this like a, right, like a grid. Going back to grade school math. There we go. Okay. We're going to go back to grade school math. We have in this case, we don't use X and Y typically to talk about these axes. We use U and V. This might be a little hard to see. Right, and here we have 0, 0, 1, 1. This is why it's really important textures be square, right? Because this value here will never be like 1.2 to accommodate a little bit larger of a texture, right? And if that's, but ultimately we can stretch these and shrink these points, right? So if this here is 0.1, what happens if we multiply this by 2? What's 1 times 2? 2, right? So, and what's 0.5 times 2? 1, right? So if we multiply this by 2, this point would move over here, this point would move over here. And our texture coordinates would become much, much bigger, right? So if we can imagine our, let's say we have like a brick texture or something here. If we scaled this up by 2, what would happen? The bricks would appear smaller relative to the 3D model. And if we divided all of these by 2 and made our texture coordinates fit in the bottom corner there, right? Our bricks would appear much larger relative to the 3D model. Does this sort of make sense, right? We've taken all of the points and edges and faces of our 3D model. We've kind of decomposed them, we've unfolded them into a 2D projection that we can then multiply and divide to change how the texture is projected on our 3D model. More or less makes sense? Clear as mud? Okay, we're going to demonstrate this. Okay. I'm going to go back to my basic surface material here. And basic surface. And I can right click and I can access those texture coordinates, those UVs in my material editor by typing in texture coordinate. Texture coordinate. Okay. And here you can see our coordinate index is equal to 0. If I go back to my cube, you can see that there's 2 UV sets. So this one, I believe it's used for like different lighting effects. And this one is just like a straight projection of our cube. Okay. Oops. Okay. So here we have our texture coordinates. If I take these, I can plug them into the UVs on our textures, right? It's going to take them and plug them all in. And you can see nothing really changes with our material. And that's because the UVs, by default, just use our texture coordinates, right? But we can multiply, just like we did with our graph there, we can multiply this to change how we scale these textures. So I'm going to right click, go, and I'm going to type in multiply. Multiply, right? We can do math in here. We also did multiplying here with our tint. But we're going to multiply this value. And I'm going to plug it into the A value. And we can create a scalar parameter value, just like we did last class, where we created all of these settings that we can use to modify and adjust our material when we create instances. But I can right click and say scalar parameter, or you can hold S and click. Scalar parameter. And I'm going to call this tiling. And I'm going to plug that into the B value of this multiply. Now, I want to move all of these connections from my texture coordinate into this multiply node. Now I could go through and click and drag this multiply node and go and find all of these connections, but I'll show you a faster way of doing it. You hold Control and you can see it's turned, and then I hover over the connections I want to move. You can see it's turned into like this little fist, right? I can hold Control, click, and just move them all there. And then hook this back up. And you're going to see that my texture is going to look like mud. It's nonsense. What's going on here? What's happened is we've taken, the coordinates, all of the positions of our vertices in 2D space, multiplied them by 0. And so now, like all of the points of our cube are right here, right? So they're all sampling this pixel on our texture, right? If I set the tiling value to 1, you can see it goes back to normal. I can set this tiling value to 2. And you can see my texture appears smaller. I can set it to 10 and it appears even smaller. Right? Does this sort of make sense what's going on? More or less, okay? You can set this to a value less than 1, let's say 0.5. And you can see it gets bigger. 0.1, right? This will make sense once I show it in the material instance and we can see it update in real time. I'm going to go back to my materials. Ooh, where are my materials? There's 2 materials here. So we created this asphalt material before. You guys might have pulled in different texture sets. That's okay. I just used asphalt. And now you can see our tiling parameter, our scaling parameter here, right? Our scalar parameter. Right now it's set to 1, but you can see I can scale it up. And you can see that the projection gets smaller and smaller and smaller and smaller and smaller until this, where it looks kind of ridiculous, where you can see, obviously, like, you can see each small tile that is our texture here, right? So here we're tiling it like 55 times on this plane, on this cube. If we set it to 1, we're tiling it once on our cube. Okay, set it to 0.5 if we want it to be bigger. Just like we can scale this, we can also move it. We can offset it, nudge it from side to side and up and down. Instead of multiplying, we're going to add, right? Right, if we want to move, say again, we have our, open up that projection again, right? If we would just want to kind of nudge this whole thing to the right a little bit, let's say, right? Well, we can't really multiply it because 0 multiplied by anything is 0. If we multiply it, this point is going to stay here, and it will only kind of move the points that are not 0. But if we want to move the whole thing over, we can just add, right? 0 plus 0.25, 0.25, right? 0 plus 10 is 10. We're going to add, we can create another scalar parameter. You hold down the S key and you click, create a scalar parameter. And we can call this offset. These are the 2 most common ways of referring to this, tiling and offset. I'll plug that into B and do the same thing where I hold control and move all the stuff from this multiply into my add. And then just connect it like this. And then I'll hit apply. And it'll take a minute and chug. Now, if I go back to my material instance, now you can see my offset parameter here. If I move this, you can see it just kind of pans the texture, right? Just kind of moves it side to side. Now you can see it's moving diagonally. And this is because our graph has 2 axes, right? But we're just plugging in 1 value. So it's, instead of moving it like in 1 direction, it's adding our scalar value in both axes. So if we add, 0.25 and 0.25, it's going to move diagonal. If we add 0 and 0.25, it'll move horizontally. So if we wanted to fix this, we could replace this with a vector parameter. Okay. And I'm going to do that right now. I'm going to hold down the 3 key and click to create a vector. Here's our vector constant. I can right click on this and say convert to parameter. And I'm just going to call this tiling slash offset. Tiling slash offset. And you can see here, if I select this vector parameter, right, we have our default value is 0, 0, 0, and 0. But you can also see if we kind of scooch all the way down to the bottom here, this is a new feature that they recently introduced, where we have our parameter customization and our channel names, right? So we can actually kind of put 4 parameters into a single vector. So I'm going to set my channel names R to tiling U, right? Because we use their axes, U and V. You could also say tiling X and Y if you're more comfortable with that, if you feel like it'll be clearer when you look at this later. We can set our G value to tiling V, our B value to offset U, and our A value to offset V. And so what we're doing is we're taking a color and we're splitting it into 4 values, because a color is made up of, in computing, 4 channels. Red, green, and blue, that's going to control the mix of these primary colors to create your color. And then a 4th channel called alpha that controls the transparency of the image and the color. For the defaults, I'm just going to set all of these to 1 just to be safe. Now we need to multiply our texture coordinates by, basically we need to kind of convert the U and V value here into a separate vector, right? And we need to convert the offset U and V into another vector. Now, I won't get too much into HLSL, but this is just kind of like a wrapper for another programming language called HLSL, or high-level shader language. And in high-level shader language, you don't have vectors, you have something called float 2s and float 3s, which just means 2 floats or 3 floats packaged together. So we can right-click and say make float, and you can see we have these 3 functions: make float 2, make float 3, make float 4. I'm going to grab make float 2. And here you can see it takes an X and a Y value, and the result is a vector, right? An X and a Y vector. So we can take our tiling U, our tiling V, plug that into the B value of our multiply. We can do the same thing. We can say make float 2, take our offset U and our offset V, and plug that into the add value. And I'm just going to get rid of this tiling and offset parameter here. Okay. Now if I go to my material instance, now we have this vector parameter here for tiling / offset. And now if I just want to move it in one direction, I can grab my tiling U. You can see it's just moving to the left and to the right. And we have our, we can scale it in individual axes. If we want to make it really squishy, we can do that. Right? Because now you can see we can multiply, instead of multiplying the whole thing, we can multiply it in one direction, in another direction. We can offset it in one direction or another direction, right? Okay. I'm going to go back to my material here. And the first thing that I notice is that this is starting to look a bit like spaghetti, right? It's really hard to tell what's going on here, right? So let's see if we can clean this up to make it a little bit easier to read, a little easier to tell what's happening, why we're doing things. To do that, I'm going to create something called a material function, right? So just like with other programming languages, we can create reusable kind of snippets of code, right? Reusable snippets of code. And what I'm going to do is maybe this kind of texture coordinates, tiling, and offset. Maybe this is a pretty handy piece of code. I don't want to have to rebuild this every time I create a material. I'm lazy. I want to be able to just copy and paste this. So what I'm going to do is I'm just going to grab all of this and hit Control C to copy it. Just grab it all, Control C. Okay. I'm going to minimize, and I'm going to go back to my content browser here. And I'm going to right click. And if we go down to this materials tab here, you can see that there's all kinds of kind of more advanced aspects of materials. But here you see we have our material function. Okay, material function. I'm going to click on that. And I'm just going to call this MF tiling offset. MF being short for material function, just like M is short for material, MI material instance, just to keep myself nice and organized. I can then double click on this material function. And you can see it's the same thing as our material graph, except we just have this one output result, right? I can press Control V now, and all of that stuff that I just created has been pasted into here. I can take the output of this add and plug it into my result, right? Now, if I go back to my material, so this is my one with all the textures, all of the fancy stuff here, I can just click and drag my material function into my graph. Okay. I'm going to check something actually. There is a way to get it to expose these. Like if you just right click, it'll show up in the menu. Okay. If you are in your material function and you don't have any nodes selected, right? By default, the output result will be selected. Just like kind of click on the background in the graph here somewhere. And you'll see in your details panel on the left-hand side, we have some settings for the function. We have this toggle exposed to library. Exposed to library. If you set true, anytime you're in a material, you can just right click and search for your function. And now you can see here's my MF tiling offset function here. I'm not sure what all of these other MF tiling functions are. They may do something similar. Unreal Engine provides a whole ton of material functions by default. But you can see here's the one that we just made, MF tiling offset. Here it is. And then instead of having all of this gunk here, I can hold Control, just plug in the output there, and then I can just get rid of all this, right? When I'm working, oftentimes, you won't, like when it comes to like the overall material, you won't see all of this. It'll be like 3 or 4 of these blue nodes strung together and then plugged into the output. All of the kind of stuff behind the scenes gets broken up into functions because you can just name the functions to say what's going on in that subgraph, right? Let's see if we can clean this up even more. When I'm making materials, I like to avoid having all of these kind of like squids, I call them, right? Where you have this one node with a million threads connecting, going through other nodes. It's very hard to tell what's going on here, right? What we can do is we can kind of, sort of can define variables in our material. They're not really variables, but they work kind of like variables. I can click on my result here. I'm just going to click and drag and release. And I can say add named reroute declaration node. Right, and now I have this blue node that I can name. I'm just going to call this UVs. And the reason I call it UVs is because that's what the name of this input is. And then instead of having this node kind of, again, this big squid with a million tentacles connecting all of these things, if we accidentally break any of these connections, who knows how to fix it? It becomes a whole nightmare. Instead, I can just click on my UVs, drag, and you can see we have this named reroute menu up at the top. And just grab my UVs, right? Click, drag, named reroute, UVs. And the benefit of doing it this way is, let's say, I want to do some animations with this, right? So we've discovered that we can kind of like multiply and to scale it, and we can offset to move it. Well, maybe I want to animate the offset. So instead of this just being like static rocks, it kind of moves so that it looks like a, I don't know, like a mudslide or something. All I have to do is do whatever I'm going to do here, and then plug it into this named reroute node, and it'll automatically be applied to everything that uses the UVs. So this is why this is a handy thing. I'm not evaluating you based on your use of named reroute nodes, but they are handy, especially if you are interested in doing anything more complicated than like a very basic material. I use named reroute nodes all the time to help me keep track of what's going on. Another way we can clarify what's going on is you can select a bunch of nodes and then press C, and that'll add a comment box. So all this here is my base color. I can just say base color. And then I can move around all of the nodes in the box together, right? So again, you select a bunch of nodes, press C, and move this over here. And I can call this roughness. I generally only do this if I have like a whole bunch of nodes that all produce a single output. So for example, this one here, where it's just like UV's normal texture gets plugged into the normal channel, like a comment is not going to clarify what this is. I'm sampling a texture, plugging it into the normal channel. If it's really painfully obvious what is going on, you don't really need a comment. Okay? You can do the same thing here. Select all this, press C, call this displacement. And this is nice to do because now if I zoom out and I'm looking at my whole graph, I can kind of see at a distance base color, roughness, displacement, right? It just makes it easier to read, easier to tell what's going on at a distance. I also said that Unreal Engine provides a whole bunch of material functions. If you right click, here's a good example, MF Fuzz. This is something that makes like a surface look fuzzy, kind of like moss or velvet. So I can place this in here, MF Fuzz. And if I double click on this, you can see that you can actually go in and mess with and see how all of the very talented shader artists at Epic Games, all of the math that they've done, how they've structured their code. It's all freely available. You can go in and take a look at it. This is honestly just by doing that, just by looking at the material functions provided, double clicking, opening them up. That is how I learned 99% of the math that I apply to shaders. I don't have like a specialized education for this. You just go in and you learn, right? You've got to be curious if you want to do anything in game development. Anything artistic, you just have to be curious, right? MF, okay, we can adjust our normal strength, temporal blur. I don't know what that is. What's going on here? You can see some material functions can get kind of huge. And this is why named reroute nodes and comments are very, very handy, right? Because if this was all, again, a big bowl of spaghetti with no comments and no reroute nodes, you wouldn't be able to, you would have no idea what's going on here or why any of the math is being used the way it's being used, okay? Those are kind of the more advanced material functions I wanted to show today, which is creating material functions, named reroute nodes, as well as just the concept of tiling in UVs, right? Does anybody have any materials that they'd like to create for their levels? Anything that maybe they're not sure how to approach based on what we've covered with this? Because this is baby's first material. This is the most basic material that we could possibly build. Anything? Okay, let's try something else. So we've used materials. I can take my asphalt material now, and I'm just going to apply it to my track just to kind of show how it works. If I want to apply this, I can go to my track static mesh, which is, I believe, in template track. We have our SM track 10 meters. I can double click to open up my 3D model, and here you can see we have the two material slots for the track edges and the track, and I can just apply my material by clicking and dragging, like so. If I hit save, you can see now my track looks like cracked asphalt. I would say this kind of looks kind of bad. It looks way too big, right? Because if I then click play, this just looks silly. Look how blurry the texture is, right? It's super low resolution. What I can do is I can go to my tiling. Let's say 3 and 3. It's a little better. 4 and 4. There we go. That's starting to look like a little bit nicer, right? This is for basic opaque surfaces. Unreal Engine also supports other what are called shading models. I'm just going to create a glass material, just as a quick demo to kind of show how to do it. And really to show where you can look to see what other types of materials can be made. So I'm going to go to my content browser here. I'm going to right click, and I'm going to create a material. And I'm just going to call this M_glass. All right. If I double click on this, I'll open it up. We have our material here with all of our material properties. On the left-hand side here, if I select my output node, I go to the left side here. Under this material tab here, we have our material domain. This is where you can, so Unreal Engine uses materials for a lot of different things. Like if you wanted to make a light flicker like fire, you could use a light function, right? Which is a material. A deferred decal is what lets you kind of project stuff onto surfaces. Like if I wanted to put graffiti on this wall, I could create a deferred decal material And it would basically, the way the material works is it projects onto other surfaces, right? Volumes, post-processes, we're not really going to get into that, but you can apply a material to your screen, right? Like if you want to tint your whole game blue, you can use a post-process material because like we looked at texture coordinates, right? So our 3D model is unwrapped into a square shape, right? That we can then modify, but our screen, right, is also a 2D axis that we can use to create materials. User interface. If we have an image in our user interface, right, we can use a material. Fonts, right? If we wanted to make our font pulse and make it glow, we can do that using a user interface material, right? Anything that is a 2D projection can be done using a material. These are all kind of more advanced applications, but if you're curious about exploring them, you can look at the material domain. Just beneath that, we have our blend mode. Right here, you can see this is opaque. But we also have masked, right? Masked just means that there is kind of a black and white value that shows transparency, right? So for example, imagine we have leaves on a tree, right? Our 3D model might look like this, but we want this to look like a leaf, and our leaf texture is like this. We could use a masked shading model, make all of that invisible, okay? And then we have translucent. Translucent, right? If I click on that, you can see that this kind of gets grayed out. We lose our metallic, our specular, roughness, anisotropy, but we gain this opacity value here. I'm just going to quickly create some parameters. I've gone through how to create parameters. You can hold down 1, 2, or 3 to create constants of, one, like a scalar or different vector constants. And then you can right click on these and say convert to parameter. So I'm just going to quickly whip up some parameters here, base color. I'll right click on this, convert to parameter, opacity. And that should do it for glass. We'll add some refraction to this in a minute. So you can see my opacity value here is set to 0, and I can't see anything. It is perfectly transparent, and there's no refraction, so it is invisible. But if I increase my opacity value, say, I'll set it to like 0.7, you can now see it's kind of a little bit see-through. I can change my base color to make it kind of like a see-through, maybe like a stained glass green color. Okay, so this is the basics of how we would do kind of baby's first glass materials. You could go translucent, but what if we want to do something like frosted glass? What if we want refraction, right? So when in reality, when you have a pane of glass, right? So here's our pane of glass, and a ray of light comes and goes through our glass. What's going to happen is it's going to kind of bend, right? Same thing with water, right? When you look through water and you're looking at a surface beneath it, it kind of ripples and warbles a little bit, right? So let's add some refraction to our glass. Let's figure out how we can do this. Again, I select my output material for glass here. So here we have translucent. Our shading model is default lit. If we click on this, you can see there's all kinds of shading models that are provided. Default lit is what 90% of materials use. Let's say you want to do like a car. You could use a clear coat material, or varnished wood is another example, which is basically, let's say you have surface of a car here. This is would be like a metal, like aluminum or steel. And clear coat, what it does is it adds kind of a thin layer, right? So this would be like a shiny layer, and then so you can have kind of layered materials. Let's see if we can do something here. We can do subsurface, pre-integrated skin, clear coat. Maybe none of these. Let's just search for refraction. And here you see we have this tab for refraction. And right now our refraction method is set to none. So it's saying, nope, you can't refract this surface. Not going to happen. If I click on this, you can see we have a couple of options. 2D offset is kind of the cheapest and worst looking one, in my opinion. And pixel normal offset, I've never really used it. I believe the way it works is, so you can see we have the scene color that's kind of showing through this. All it really does is it kind of takes the final rendered output and then multiplies it. And then you have my favorite, but also the most costly in terms of performance, which is the index of refraction. If I click on this, you'll see we get two new inputs to our glass. We can now input a normal map, and we have this refraction input here, index of refraction. So I'm going to start just by dragging one of my textures in to be a normal map. I'll just use my paving stones normal for now. And I'll click and just plug this into my normal. And now you can see my glass has a bit of texture to it, right? There's a little bit of that, kind of roughness, kind of bubbliness that comes from this texture. I'm going to create another scalar parameter. I'll convert to parameter here and say index of refraction. Now, I believe air has an index of refraction of 1, which is to say it doesn't really refract light too much at all. But something like water is a bit higher, like 1.34, if memory serves. If I plug in this higher index of refraction, hit apply. You can see it sort of starts to bend the background just a little bit. Let's create a material instance of this and see if we can really crank this refraction to just get a really kind of messed up looking glass. It's really kind of bending everything behind it. To do this, I'm just going to go in here and I'm going to grab a cube. Just want to create a quick pane of glass. I'll make it nice and thin. And then I can just drag and drop my material onto it. So I go to my materials folder. Here I have my M glass. I don't want to just drag and drop my master material on there. Just like with our basic surface, I'm just going to right click and create a material instance. And I'll call this MI glass test because I'm just testing to see what this is going to end up looking like. And to apply a material to something in the world, you can just click and drag, and you can see I've applied my material. Oops. So let's see what it looks like without it there. It doesn't seem to be refracting all that much, so let's see if we can kind of crank the refraction a little bit to see what happens. Set this to maybe 0.34, and maybe reduce my opacity just a hair. And maybe set my base color to white just so it's a little bit clearer what's going on. If I move this, doesn't seem to be refracting as much as I would like. That's the gist of it. Come on now, why am I moving so fast? There we go. I believe also refraction does require a bit of looking at an angle. And it just sort of bends the light a little bit behind it. Okay. That's just the general idea. If you're ever unsure of how to make a material, you're like, oh, I want to make water, I want to make glass, I want to make grass, foliage, I want to make trees. Select your material and just kind of go in and explore these three settings here: material domain, blend mode, shading model, and just look at these different settings to see if there's something that will let you do what you want, right? So like here we can apply different sets for our translucency. I believe volumetric, directional, like you can see there's a lot of different options you can do here for translucency, and it depends on what kind of translucent surface you're making. It's like surface forward shading is a little bit more costly. But might get us a better result. You could also do just kind of experiment with them, honestly. This is just kind of experimenting with it a little bit, figuring it out. And glass test, here we go. It's just giving us yeah, we can see with surface forward shading, we can definitely see a lot more of the normal map coming through than we could before. And it's still not getting great refraction, but anyway. Any kind of questions about this? I know your lab, your final lab, so this will be lab number 4. One of the options is to go through and create different kinds of materials for like ice and glass, and basically to do research and figure out how to do it. If you have any materials you want to make and you're not sure how to approach or what some good resources would be, you can always reach out. Yeah. Materials, what else can we go over today? This is really all I wanted to go over for this week's class, is to kind of finish up, wrap up materials. We don't need to think about it. Yes? Oh, for the glass here? I just found my texture in my content browser and clicked and dragged. But if you want to set the texture sample manually, you can do that too. I'll just let this finish compiling. It's just going to take a hot minute. So if you select your texture sample, in the details panel on the left-hand side here, you can see this texture, and you can just go through and find your texture asset here. What else would be a good thing to show for materials? I kind of don't want to distract too much, just because your final assignment only really requires you to create one master material and 2 material instances from that, using kind of the basic material that we've created so far. Yeah, again, I kind of don't want to. I suppose I can show you how to import 3D models. Now, that's a really fast thing to go over. So just like with materials, we can find 3D models online. So I'm just going to open up my web browser here. And there's lots of kind of free sources for 3D models online. You can go on to fab.com. This is the one that Unreal Engine provides, and you can find some free 3D models on here. Another one that I also like is called texturehaven.com. Yeah, they've rebranded to Polyhaven. It used to be that all they had was textures, and now they have all kinds of 3D models and HDRIs and stuff. And if I go to assets and models, you can see that there's a whole bunch of 3D models that you can import, like foliage and boulders and rocks and stuff. When you're just kind of like looking for them and downloading them, there isn't always a guarantee you're going to find exactly the right one that you're looking for, but nonetheless, they're here. Okay, so here's this rubber duck toy. I'm just going to import this into Unreal Engine and show you how to bring in 3D models to, make your, kind of personalize your level a little bit. right, so once you've found a 3D model on any site, this is just the site that I'm most familiar with. A lot of times they'll also offer options for resolution. Obviously, lower the resolution, the easier it's going to be to download and push it to Git. This is actually an interesting one here. Like you can see, it says 1K and then it says 18.2 pixels per centimeter. That's kind of what I was talking about with texel density, right? So pixels per centimeter should be like 1 or 0.182 pixels per meter, something like that. And that's because this is obviously like a really small 3D model. And so the textures, 1K, basically would be really big relative to the world. But we'll see how this looks. We have this other option here. We're going to download an FBX. And I'll show you what that means in a second. I'm going to click download. And just like before, we get a zip folder. So before we downloaded materials for like asphalt, paving stones, bricks here. And this time we're downloading a model. I'm just going to extract these really quick. And here you can see we have this rubber duck toy underscore 1k.fbx. FBX stands for film box, I believe. It's basically an industry standard way of saving 3D models. Unfortunately, it is a proprietary file format owned by Autodesk, which I kind of hate. But yeah, you'll see FBXs is usually how you'll find 3D models. And if I want to import this, I'd probably start by creating another folder for myself. So I'm going to create a new folder and call it like static meshes or models, meshes. Just a folder that lets me know where your 3D models are and keeps yourself organized. And so with my file browser here and Unreal Engine here, I can click and drag my FBX into my content browser. And we'll get this window here. So the main thing that you have to think about is here you see this import uniform scale. And this is because when you create when a 3D model is created, it's created in a software, usually something like Blender or Houdini, Maya, something like that. And just like with Unreal Engine, where we just say, okay, 1 unit is 1 centimeter, that's just arbitrary, right? It's not a real space. We just kind of set it to what it is, and each software has its own unit scale. So sometimes you'll find a 3D model that was created in a software that has like 1 unit to 1 meter or 1 unit to 1 kilometer, whatever. And so you might need to, once you import it, if it gets scaled incorrectly, you might need to re-import it and just like mess with its uniform scale until it is scaled correctly. And then we have here search location. This is basically if the 3D model has a material and textures associated with it, it'll automatically import those as well. And we'll see if this one does. We'll see. And I'm just going to click import all. And you might get a couple of like warning messages like this. Generally speaking, you can just ignore them. Unless it crashes your computer, in which case you can't really ignore it. Okay. So it looks like this 3D model had all of the textures associated with it. And Unreal Engine is very nice in that it creates a material for us. However, the downside of this, right? If you remember what we discussed last class, every time we create a material, our project performs a little bit worse. So this is why you should just be careful. And if you can, you should create a master material for all of your 3D models, just like we did with our surfaces. You can create a material for your 3D models and use material instances instead. It takes a little bit more work, but you know, for your purposes where I only expect you to import 1 or 2 models, it's probably not going to make a huge difference. But If you start importing hundreds or thousands of 3D models and they all have individual materials, your computer is going to take a million years to load your project, and it's not going to be great. So I look at my material here. Looks like we're getting some errors. It's saying texture sample type is normal, should be linear color. Interesting. Ah, okay. This is a good learning experience here. This one's saying it should be color, but should be linear color. No, it should be color, but we'll set it to linear color to see what happens. Okay. So our normal map that we imported is throwing a bit of an error. And you can see we have this rubber duck toy NOR, which stands for normal underscore GL. In computing, there are kind of three competing rendering libraries, right? And these are the code libraries that lets your computer talk to your GPU and tell your GPU what to render on the screen and how to render it. Unreal Engine uses one called DirectX, but there's two other really big ones called Vulkan and OpenGL. So if we double click on this here, we can see the normal map for our what do you call it? Our rubber duck here. And it looks a little different from, say, the normal map for our paving stones. Right, you can see it's almost like this kind of light pinkish hue. And the only real difference is, if we think about this material, we're using color to represent a direction, right? And so if we have our red, green, and blue value, our blue value is always pointing in the direction of the surface. All we're doing is we're saying use the red value to bend it, say, this way, and the green value to bend it this way, right? With OpenGL, it uses the green value to bend it this way and the red value to bend it this way. It's an easy fix. So if ever it's throwing you an error, there's an option in here somewhere called like flip green channel. Yeah, there we go. See, it's a common enough thing that Unreal Engine is like, yeah, just flip the green channel. And you can see now, right? Look what happens. Like here it's kind of pushing out, and here it's pushing in. We're just going to flip that green channel and hit save. And let's see if this material is still throwing us an error. It is. Sampler type is normal, should be linear color. So I grab my texture sample, I go to my sampler type. Why is it asking for linear color? I don't know why. I'll just hit apply and see if it works. It should be normal, but it's not, so just do what it says and see what happens. Okay, and here now we have our rubber duck that we've imported. I would say that we're getting some weirdness here. So like there's like this seam that kind of splits it down the middle. So I might need to go in. This is probably an issue with the normal map. So it might be some debugging there, but the bottom line is now we have our 3D model of our rubber duck. If we want to add it to our scene, we can just click and drag it into our scene. Okay. But you can see it's kind of composed of two parts. We have the actual 3D model itself, and then we have the material. And this is a really good example actually to show UVs. I'm just going to open up my 3D model, and you can see this is the UV projection of our duck. It's different from our cube, but this basically what they've done is they've kind of sliced it up and they've created all of these little islands that if we assembled all of these pieces and sewed them back together would represent our duck. I would guess that this here is probably the beak or something. Maybe down here is the beak. But if we open up our textures, right, this kind of looks nonsensical. Like, this is super weird. But when you think, okay, like, let's go back to our 3D model here. I'll just kind of open these up in separate tabs so we can see. We can kind of start to see how our texture gets projected using this 2D thing. So I think these pieces here, like right here and right here, and probably these two pieces here are the beak. So you can see this whole quadrant down here is red, and it lines up with where all of these pieces of the beak are. So that's how we're projecting that red color on the beak. And it looks like this here is probably the head, and you can see the eyes here. So this is the head split up into two pieces, and we project the texture this way, right? When it comes to 3D models like this, you almost never scale and offset the UVs for this reason, right? It's made like the textures themselves. If I tried to scale this, it just wouldn't work, right? Like if I move this piece away from here, well, now our guy has no eyes, or even worse, the eyes start to show up on the duck's chest or something. It would just be weirdness, okay? So for 3D models, you can't really scale and offset. You can only really do that for kind of general surfaces, that tile, okay? So Polyhaven, that's one good source for 3D models. Oops. You can see they also have textures as well. So you can look here and they have all kinds of like photorealistic textures. There is, again, Ambient CG, ambientcg.com. And you can see here they have 3D models here. So this is where we found our materials last time. They're pretty limited. I think they just have like a bunch of food and maybe a couple of landscapes. So not a whole lot in the way of 3D models here, but if you want to do a food-based level, I guess you can do one. Yeah, that's kind of the basics of importing 3D models. This is definitely the easiest part of your final assignment, is just to like pick two models and import them and put them in your level. Yeah, and that's basically it. We're going to kind of end a little early there. Mostly because I just don't want to keep talking at you. This is an opportunity for you to work on your assignments. I'm here to answer any questions if you're having any issues with your assignments. If you're just curious and you're like, I want to make this type of, I want to make a river, I want to make water. Well, we'll make water, you know. And that, we're kind of done for the day. We're wrapping up a little early. Any questions about what we covered today? Good question. I'm going to open up my blueprints here, find my cart. I'm going to go to my viewport. So here's my cart with my collision, my 3D model. And I just want to add another static mesh component to this. So I'm going to add a static mesh component here. And I'm going to select it. And then my details panel here, we have our static mesh, and we can set this. I'm going to set it to my rubber duck toy here. And you can see it's facing the wrong way, so I'm going to just rotate it around like so, just so it's facing the right direction. What's likely happening is your duck is colliding with your car. So what we can do with our static mesh selected, we can come here to collision. And here you see it says block all dynamic. We can just say no collision. That way it doesn't collide with anything. Also here, because probably what's happening is it also has gravity enabled by default. So what's happening is your car is trying to go forward and your duck is pushing downwards on it because gravity is being applied and it's placing downwards force on your car. And then your car is trying to move forward and they're just kind of like bouncing off one another and colliding and messing everything up. So we can just turn off enable gravity here. And turn off, if it has simulate physics on, turn off simulate physics. And let's see if this works. I press play. Now you can see my duck is on my car, right? Kind of fun. One place I'm going to show you, another website that has really good game assets that are free, is Kenny.nl here. I believe this is what it is. Thousands of completely free game assets for you to use. And I believe they have like a car kit. Yeah, like a toy car kit here. So if you wanted to import a car and replace the box 3D model that we're currently using, you could come in here and grab a car. Let's do it. We got 10 minutes. I'll download this. I don't want to donate. I work hard for my money. Give me free stuff. So I've gone to Kenny NL, found this little toy car kit, and I've downloaded it. And just like before, I can come here and I can extract it, extract all. And it'll take a minute. Yeah, it looks like it provides cars as well as wheels. So we may be able to do our wheels separately. But we'll see actually like how the assets work and kind of how he structured this. It also provides us some track models here that might be fun to use. If you want to replace your 3D model of your track with something like one of these. It's a pretty good one, actually. It's a pretty good asset kit. And yeah, if you have like a kind of general kit that you're looking for, looks like there's a whole bunch of assets. Like you want to do a Lego themed level, there's a bunch of that. We have this car kit here, which has a whole bunch of different cars and tires. Probably pull one of those in. Okay, here we go. We have unpacked this. We can go into our models. And you can see we have different formats. Like I said, FBX, that's the format we're looking for. And we can just kind of pick which one we want. I'm going to bring in this vehicle monster truck FBX. So I can again just open up Unreal Engine, go to FS2 to my static meshes folder. We'll see how he's formatted this. The reason people like FBXs is because they can also store animated things. And so sometimes they'll come in with animations, other times they won't. We'll see. The way that you would import it as like an animated mesh instead of a static mesh is we have this little toggle up here for skeletal mesh. So if it has animations, if it has a skeleton, that's what you'd toggle. I don't know if this one has a skeleton. I would need to open it up in like, I don't know, something like, okay, it looks like this does have a skeleton. I'd have to open it up in something like Blender to see, but I'm not sure. So let's see if this is it, because you can see it's imported all of the wheels and stuff separately, which is actually kind of a good thing for us. Because our car kind of bounces up and down, we would probably want the wheels to be separate from the body so that it looks like the suspension is moving. But let's just replace our box here with this monster truck to give ourselves an interesting car to use. And come on now, here we go. So I can come in here, I'm in my cart, I have this box collision, and then I have this cube, which is just a static mesh material. And what was this called? It's called Monster Truck. I'm gonna grab my cube and say Monster Truck. And you can see it looks a little goofy just because it's scaled weird and rotated weird. Rotated maybe 270. 270. Okay, now it's facing the right direction. 1, 1, and 1. I could kind of rotate this around maybe. And just kind of scale it around and move it into place. And then I would probably want to import add 4 more static meshes for each of the wheels. I could even do something fun where, I get the speed of my car, which we did for our widget for tracking the speed, and then we can rotate our wheels based on how fast we're going. We could have some fun with that. Not really going to cover that. If you wanted to import the 2 3D models that you need for your assignment, if you wanted to do a car and its wheels, it's a good idea. Kind of do this, scale it up like so. Now if we press play, you can see now we have a monster truck. Now I am curious to see if this is a skeletal mesh, which has animations. Because if it does, that's something we can go over in the review class if somebody's interested. I'm going to bring in this SUV and see what this does. I'm going to turn on skeletal mesh. You can see we don't have a skeleton, so it'll import the one that we bring it in. I'm just going to say import all. Or I'm curious. Now, if I open up this skeletal mesh, aha, they do have rigs for an animation. Interesting. Very interesting. We're not going to go over this today, but basically the difference between the models that we've imported as static meshes and skeletal meshes is right here. You can see it has these 4 bones, I guess you would call them, right? Because then we can then animate these bones to make the wheels spin, to make the suspension bounce up and down. Beyond the scope of this class, not an expectation, but it is interesting that these are rigged. So if we want to animate these cars, that could be something fun. And I wonder if this guy's other assets are probably rigged too, if he has other kits. Okay. Anyway, that's it for today. I got to let the next class in shortly. So yeah, that's actually going to be kind of fun. Yeah, animated characters. He's got all kinds of stuff here.